This recording will cover Chapter 9 in your textbook, all about math. Woohoo! Finally, we're at my chapter, people. Um, if you have not already taken with me one of our math classes, you will shortly. So you will have me for the math class in your program. And I can't wait to teach it. I'm very excited. So I'm glad that math is not the last chapter. Math is always the last chapter in a textbook, and it makes me very, very sad. But in this one, the PowerPoints, there's only 11 slides, whereas in some of the reading chapters, there are a lot more. So I'll be okay with the fact that it's not the last chapter, and I'll be happy with that. So this is some strategies and techniques for teaching math to students with high incidence disabilities. Again, make sure you go into your chapter, into your textbooks to get some even more ideas, and it'll go more in depth than this PowerPoint will, okay? So we just want to think about all of these things, especially the challenges that problem solving, advanced levels of math might pose for some of these students, as well as some effective instructional responses and effective instruction in general, okay? So some foundational mathematics knowledge and skills. So thinking about things, this is typically these kind of early number skills, excuse me, typically happen when students are 3, 4, 5, 6. But for students with high incidence disabilities, they're going to be in some of these kind of stages, if you will, for a lot longer than some of your other students. Okay, so for example, number sense is a pre-skill necessary. Whoa, I'm going to pause because something weird just happened. Okay, I'm back. Sorry. Something really weird just happened. Anyways, number sense is a pre-skill necessary for math involving understanding how numbers relate to one another as well as the mathematical value of each. All right, one-to-one correspondence, recognizing that units have numerical values. Vocabulary. People are not often using math vocabulary unless they're in math class, right? So people aren't running around on the playground saying, I'm a parallelogram, I'm going to get you. They should, but they don't. Okay, so vocabulary for numbers. That's naming and understanding mathematical concepts such as whole numbers, integers, and rational numbers. There's also, and it's not on here, but there's also vocabulary of computation, terms including add, subtract, multiply, and divide, as well as terminology for the outcomes of those operations, okay, product, sum, stuff like that. And then vocabulary for relational concepts, being able to name and demonstrate which sets are the same and different, as well as which sets or numbers are greater than or less than others, also known as quantity discrimination. All right, place value, identifying the value of each digit in a numeral, ones, tens, hundreds, etc. Classification is, grouping objects by like properties. In kindergarten, they start, or even earlier than that, you might say, put all the red teddy bears over here, put all the green teddy bears over here. That is starting classification. And then counting, right? Just regular old counting. So counting is a vital skill for computation. Students can master it via one of several ways and must do so in order to master especially addition. So counting by is a strategy for mastering counting and calculation operations involving skip counting by a certain number, such as counting by twos, fives, tens. We do that often, right? Counting backwards would be just counting down or a descending count. And then counting down is a strategy for mastering and counting involving starting with a larger number, such as 10, and counting downwards from there, okay? So those are some of the key terms that we need to be aware of. So some other skills and concepts tend to be taught, well, this is a way that I advocate for, in the concrete, semi-concrete, or semi-representational, some people call it abstract. So some people call this the CRA sequence or CSA. Okay, so concrete is concepts that are basic to mathematical understanding, such as can be calculated using manipulatives or something concrete in your hands that are not representational or abstract in nature. Okay, so that's where we're going to get. So we want to start with concrete. So giving them those green teddy bears to add and subtract, giving them something they can hold in their hands. Okay, then semi-concrete, or again, it's also called representational. all right, where a symbol or, a picture would represent the concrete object that we just talked about a few minutes ago. So semi-concrete is depicting a math problem by drawing it or representing it with hash marks, etc. Or you might say, draw 5 apples and take away 3. So they might draw 5 apples after they've worked through the concrete stage, right? They would draw 5 apples and then make 3 hash marks to represent taking away 3. And where we want our students to get, where we want all our students to get, is to the abstract phase, depicting a math problem by writing it in number form. Okay, so again, if concrete was giving them, 5 apples, semi-concrete or representational was drawing a picture or hash mark to represent 5 apples. Abstract would you would say, oh, you started with 5 apples, and you know what they would write? The number 5. Okay, so that's what we mean by that concrete, semi-concrete, or representational and abstract. I kind of like the representational just because I always call it the CRA sequence. But again, CRA or CSA are both really important sequences in math, especially for our students who struggle. Okay, some basic concepts, computation concepts, addition, adding more, subtraction, oh, taking something away, multiplying, thinking about groups, right? It's really repeated addition is what multiplication is if you think about it. And division is repeated what? Repeated subtraction. I hope you all said that. Okay, we also have, oh boy, the dreaded fractions and decimals. Students just kind of lose it when numbers are not whole numbers. I am currently teaching a math class right now to our undergraduate students, and luckily we don't cover fractions in this particular course. They'll get them in the next course in the sequence, but they're already talking about fractions. And these are college students, so think about our students with high incidence disabilities. Oh boy, the dreaded fractions, let's just call it that. So we also want to think about other basic skills for mathematical operations, daily living, estimating, stuff like that. So that, comes into play when, okay, I have to be somewhere at 1:30. Well, I have to think about, okay, how long will it take me to get ready? Well, it might take me about 17 minutes. Okay, I'm going to round that up to 20 minutes. Okay, then let's see, I have to drive my car for 20 more minutes. Okay, so let's see, I'm already at 40 minutes. Then there might be traffic or there might be a train, which I always hit, or get stuck by, I should say. Oh, so that might add on 10 more minutes. And then it takes me about 10 minutes to find parking and to walk to where I need to be. Oh, okay, I have to be there at 12. Oh, that means I have to be there at 1. Oh, I probably need to leave close to 1 o'clock. So kind of that rounding, estimating, stuff like that, okay? Rounding up is a process students use to convert numbers that they are good at counting by to compatible numbers, in this case, counting up. So maybe if a student has the number 8 and they have to do something with the number 8 or 9, they might round up to 10, right? Sometimes 10 is just easier to work with. Well, not sometimes, usually, always, 10 is easier to work with. And then rounding down, a process students use to convert numbers that they are good at counting by, again, to compatible numbers, in this case, by counting down. Okay, so you might round down as opposed to rounding up. Front-end estimation is a process in which students observe the numerals that are left most when adding to estimate the correct place number for addition problems. So they might look at it and say, 32 plus 26 or something like that. And they might estimate, oh, well, okay, 32 is close to 30, 26 is closer to 30 also, right? I might be forgetting my numbers because y'all know I'm old when I do that. Oh, so I think the answer is going to be around 60. And yes, I have my dog here and I'm on campus and there's all sorts of people walking by in suits, so we don't really know what's going on. So some big ideas are just the major concepts of a curriculum, which can serve as an anchor for learning other less independently relevant concepts and skills. So kind of what ties everything together, what ties the curriculum together. So some challenges to problem solving. Well, motivation, right? Especially in math. If you ask people, How many of you like math? You're typically not going to get a very high response, unfortunately. So motivation is a desire to learn based on recognizing the relevance of math to everyday life. You will hear that so many times. Well, when am I ever going to need this? Why do I need to know this? How is this important to me, right? So students struggle with motivation because they don't see the relevance, okay? They also might be lacking in some of those prerequisite concepts or skills. Maybe they never got them in earlier grades. Maybe the teacher just kind of passed over them thinking, oh, my students, they don't need to know this. It's too hard for them. They don't need to know it, but sometimes they might, okay? Mathematical literacy, being able to read and comprehend mathematics problems. And then confounded problems, those that include extraneous or confusing content. So that might be where you have to use the strategy of highlighting, let's say. Oh, let's look just for the, Georgia, let's look just for the important facts. Okay, and then also complex math tasks, tasks that require students to perform multiple operations to arrive at a solution. We know, especially as students get older, math becomes even more complex. So how are we going to respond to some of these challenges and problems that your students are going to face? Well, you might want to think about task analysis or task analyses. A task analysis for a lesson, teachers identify prerequisite knowledge and skills as well as co-requisite, what else did they need to know at the same time, knowledge and skills needed to accomplish the lesson goal. And then there's also task analysis of student learning. So that means this is when teachers can ascertain what a student knows and does when attempting a task. Can you look at a student's work and say, oh, I can totally see what they're doing here? You also want to think about, and I don't think this is in either of any of the slides that are on the left. You want to think about errors and error analysis and looking to see if you can figure out, is there a pattern in your students' errors? Are they making the same errors every single time? And is that something you might need to go back and reteach? Okay, some strategies: draw, fast, and solve. Again, those are in your textbook, and I actually talk about these. I did a presentation over the summer in Columbia, and I talked about all three of these strategies. But make sure you go into your textbook, and it explains draw, fast, and solve. When you're teaching strategies, you need to make sure that, I'm going to skip this slide for 1 second and come back to it. When you're teaching strategies and math in general, you need to make sure you're really explicit with what you're teaching, okay? And when you get into our math class for your program, we will talk a lot more about explicit instruction. But you want to think about systematic instruction in specific skills. I'm struggling with words. Systematic, excuse me. Okay, so coordination of the order for teaching specific skills, including prerequisites and co-requisites. What do they need to know before they get to this particular skill, but what might we be working on at the same time? And you also want to make sure that you are constantly reviewing prior knowledge and skills. So especially in math, you're not just going to teach them something once and then be like, okay, well, we're never going to see that again. Bye, see you later. No, especially in math A, and especially for these students, review often, okay? So systematic instructions, very explicit. Watch me, let's do some together. Now it's your turn. Coordination of the order for teaching specific skills, really kind of thinking what you're going to teach first, and then again, any prerequisites and or co-requisites, and then review as you're going along. And I know I skipped this and I came back to it. So some general approaches to math instruction. PALS math. This is peer assisted learning strategy. Okay, and it's PALS also exists in reading. Math is newer, but there are 3 different programs, I believe, for math. There's let me make sure if I'm right. I think there's kindergarten and first, I think, is one curriculum, PALS. Then I think there's like second grade or second through third. And then there's also high school. I believe there's high school. I might be lying about that because I know they came out with high school reading, but I might be 100% lying about math. But you should look into it, peer assisted learning strategies. It's a really neat program. And then again, direct instruction, kind of what I just talked about, that very explicit instruction. Watch me, I'm going to show you how to do these things first. Okay, so that is it for math. Hooray, math was not the last chapter. I'm going to leave you with a joke. I apologize if you've heard it in one of my other classes, but I'm going to say it anyways because it's about math. So I had a hen once. She could count her own eggs. She was a mathema chicken. I'm going to leave you on that. Feel free to share it with your students and make sure the next time you see Dr. Nixon, please tell her that I shared a math joke with you. All right, I'll see you back for chapter 10. She was a math chicken. Come on, it's funny.